Hey everyone, thank you so much for watching the Weaviate Podcast. I could not be more excited about our next Weaviate Podcast. We're hosting Nils Reimers again on the Weaviate Podcast to discuss all sorts of things about AI and search. Sort of last time when we did our first Weaviate Podcast, Nils, we were presenting the Cohere multilingual embeddings models, and we similarly have a really exciting integration to announce with Weaviate and the Cohere Rerankers. So, I love kind of having the new update about Cohere and Weaviate, as well as diving into all these academic topics with you, because I just think you're one of the world's leading scientists on search, and it's just so much fun exploring these things with you. So firstly, thank you so much for joining the podcast.
Yeah, I'm super happy to be here. Exciting times. So I don't know, probably like half a year ago, I was here talking about multilingual. So semantic search is just amazing for multilingual setups. So especially as a European, it's nice to see work outside of English be done. And yes, super happy to talk today more about re-rank. Challenges in semantic search everyone faces at some point, and yeah, solutions for that.
Yeah, I love that first podcast, how we, describe this kind of evolution from building the sentence transformers library to now at Cohere, and how your evolution and thinking about the maintaining of this data set. Kind of, we discussed like this kind of closed source versus open source model kind of category. And we had these big topics around like, how do you handle distribution shift? What's the state of sparse vectors and the future of that? So can we maybe kind of kick this podcast off with the Cohere re-rankers, sort of what goes into that, and maybe for like Weaviate users listening, like, yeah, sort of like what they can expect from adding this to their search?
Yes, so recently, like a couple months ago, we launched a new model, a re-rank model, which is like a super cool thing. So there's still a lot of people who sadly don't use Weaviate, who are like stuck on like old lexical search systems, sometimes proprietary, where they are not able to change. And with re-rank, what you do, the API looks really simple. You put in the query, you put in like a collection of documents, top 100, top 1000 documents. And it's, as the name says, it does a re-rank. So you'd give in 1000 documents, and then it spits you out like which documents are the most relevant one. So this is like super easy to add for anyone who's not yet on Weaviate, who's stuck with like old Solar implementations or external APIs they need to use. But also in Weaviate itself, it makes really sense to do both. So do like semantic search with embeddings, get the top 100, top 1000 out of like embedding search and put it into re-rank. So as talked previously and in many other settings, there are certain challenges in semantic search with embeddings, which we'll also talk later more about. Looking forward to that. So one challenge semantic search and embeddings have is like really complex queries. So if you have like multiple facets where you say, give me, I want to know the information how Google employees changed in Europe between 2010 and 2015. So at some point, it's like really hard for embedding models to get produce the right embedding. So it's like basically embeddings are like shooting in the dark. So it doesn't know like which information do you have in your vector database. Out of your search query, it does like a shoot in the dark and then hopes that there are like 10 documents which are close by, giving you the information how Google employees changed, number of employees in Europe changed in 2010 to 2015. Re-rank is really well on these types of queries. So it uses different type of technology. Where it looks at all the documents you provide in, like all the 100 documents you provide, and then makes a decision based on these 100 documents. Okay, which one is the most, the best for your query? So it's not like a shoot in the dark. I produce the embedding and then I hope to get the top 10 with the information. By really understanding, reading all these documents you provide in, like in the top 100 list, and then telling you, okay, these are like the top 10 documents with the most relevant information. And so what we see is like really strong boost in search quality, especially on complex domains, complex queries where you have like multiple aspects. So not like a simple fact, like who's the founder of Facebook, but okay, here's like a really complex query, like, okay, which tech company was a large exposure to Europe? reported a revenue increase of at least 20% over the past year. So if you have like these really complex queries, WeRank is extremely excellent on that.
Yeah, it's amazing kind of that separation of, complex queries, like when do you need to use re-ranking? I find that all very interesting. Kind of, yeah, just from the beginning of like, you retrieve your candidates with BM25 and then you re-rank them, or with vector search. I always love, we had like this illustration early when we first started looking into ranking models. It's like thinking about it like a fishing boat where you cast like a big fish net into the ocean and then you get like 1,000 fish onto the boat. And then the fishermen on the boat are like looking for the green fish within the fish. And I always love that angle because it shows like how the ranking models are like more accurate but slower. And I feel like that's, but you're adding a really interesting extra dimension that there are some particular kinds of queries, like the multi-discourse thing, where you have this kind of funky query that you would really need to have that high precision, document and query as input. I guess, yeah, I think we can really dive into this topic of ranking generally and what ranking means in search. But quickly, I kind of want to understand a little more about the training of the ranking models at Cohere. Is this like kind of the same data set used to train the embeddings, but you train a classifier instead of an embedding model? Is that a correct understanding?
Yeah, it's similar based on similar data sets. So last year we spent a lot of time to get like a big data set in many languages. So got like roughly 1 billion question answer pairs in English, 500 million in non-English languages. And then, yeah, this is the basis for the embedding model and also like for the re-rank model. So based on these vast amount of questions people have asked and answered in the past, the model luckily knows a lot about domains, like really long tail about the weirdest subtopics you can find on the internet, and yeah, really gets this knowledge, which make them extremely powerful.
Yeah, I love that conversation topic of how you think about curating this data set. Obviously, one of your earlier works with the sentence transformers and, we're getting 1 billion pairs together. That had really inspired my interest into this whole kind of cat. I think that was just a huge evangelist for all this. So quickly, you mentioned like long tail and, I remember that 1 billion pairs, it had like Reddit, Stack Overflow. How are you currently thinking about that data set aggregation? I'm sure like for listeners, understanding how Cohere would think about something like this is a really interesting part of it.
Yes, so one challenge was in the field in general is how quickly is the knowledge getting outdated. So
Hmm.
we're producing like new words, new product names, new company names, new events, games, movies, and so on. So this is like in general like a challenge.
Hmm.
It's hitting especially hard the embedding models. So as mentioned, embedding models is like shoot in the dark. So you have like one shot, you hope to produce the right embedding without like having a lot of
Hmm.
possibilities to compare results. And so they are like really, really subjective to these issues. So if there's something new happens, um, they are not aware of. And a lot of embedding models, they are trained on like old data, like MS Marco from
Hmm.
2016 with a
Hmm.
BERT model, which was also trained on like 2017, 2018 data. So if you ask the models anything about Corona, still thinks Corona is a nice beer, a nice Mexican beer. And then if you ask like, okay, what are the symptoms of Corona? It will say, okay, you get hangover and drunk by it. So that's like really, really challenging for the embedding model. So here you would need like constantly updated information, which is like hard in terms of deployment
Hmm.
because you need to re-encode your like all your vector database. So if you go in like a billion scale, this becomes like really slow and expensive. For the re-ranking model, as you mentioned, it's like this fisherman and say, okay, look at the fish, look like, okay, where's the green fish? These are a lot more robust in terms of like
Hmm.
these domain shift out of knowledge, out of time. So here you don't need to update them as often. And also the update is much easier. So with embeddings, if you update the embedding model, you need to re-encode your whole vector database, which is slow and expensive and painful if you have like a
Hmm.
billion embeddings. But the re-rank model, it's just like one API call on top of the top 100 results you get from the vector database. So it's like really easy to update, to switch it. And yeah, so here we were aiming to have like always up-to-date knowledge in these models.
Yeah, that is a super powerful point, the robustness of the ranking models. And I hope, people listening know that, that kind of, that problem of updating, the Corona example is perfect. I won't even add anything to it, but just that kind of continual learning problem and understanding that the cross encoders, the way they attend to the query and the candidate documents, it makes them more robust to, I think we were all seeing this zero shot ability of models. And so it kind of brings me, I kind of want to talk broadly about ranking models. I understand that, like, a lot of ranking models use kind of symbolic features as well. Like, say it's like Google search, it probably has like, some information about me, like, I'm 27, I'm a male, and it will use these features as well as kind of the content and the query content, as well as these symbolic features. And you maybe give that to XGBoost, and there's some new work that's showing how you can maybe prompt LLMs with these kind of features. Do you think about those kind of features in these kind of systems?
Yes, so this is still kind of like a big challenge, big issue with semantic search. For semantic search queries, they work nice. If I ask like, what's the average lifespan of a cat? I search over Wikipedia, I find the information. But if I search like, let's say on iTunes, Spotify for updates on AI, like I want to listen to like some cool podcast updates on AI. If you just search on the text bar, on the text field, you might find like a show which has like, yeah, updates on AI. But this show might be from like 2015. It might be really poorly rated, like 1 out of 5 stars. And then there's like another show which is like, I don't know, like a week old, really highly rated, but the name is like not like Updates AI, but like, I don't know, Weekly Digest in machine learning. You as a user would prefer like the recent one, the popular one, the highly rated one over like the old one. And so this is like a big limitation. As you mentioned, a lot of people, what they do is like XGBoost or learning to rank. So basically, in the most simple form, you have like some semantic match from either like re-rank or embeddings. You have like a score on recency, you have a score on popularity, and then you do like a linear interpolation and say, okay, I don't know, 50% is semantic match, 30% is recency, and 20% is popularity. And then you play around with the three weights to give you like the final ranking. In general, it's not really fun to do this. It's like really, really brittle. So you spend a lot of cycles to play around with these three weights. Like, okay, its recency should be like 10%, 20%, 50%. If you just put like recency too high, only the most recent podcast will show at the top. If you put like popularity too high, only the most popular are shown. Even if you like, I don't know, do like a really niche query, long tail query where it's okay, I'm really interested in these one. Tiny podcasts, you're not able to find it. And then you try to balance it between these three factors. And so, yeah, so I think there's a lot of potential here to make it better, where we're also like working on it, like rethinking, like how can you, learn these as part of the model.
Yeah, I think like if I can just kind of continuing on the potential of this, I think, having the LLM and prompting it where you get each search result is like a JSON dictionary, and the keys are like content and then the text content, and another key might be, date published is probably a good example when you want to sort by recency, and sort of as you can just prompt the LLM to like, please, re-rank these, but prioritize recency, but like not at the cost of if it's not relevant, like that kind of soft, fuzzy prompt, and it's still able to kind of interpret that. And I think the distillation of the LLMs into the Cohere Rerankers for that particular task, I love that topic of like distill LLMs into some specific task. And I think the ranking is just the perfectly set up for this. So I think this would actually transition really nicely as we come into our academic topics to talk about temporal queries and how you're thinking about that.
Yeah, so temporal queries, it's a challenge. So it's like really a lot of people go into like semantic search. So you see a lot of people really testing around, and yes, sadly, embeddings itself, they don't have like a temporal understanding. So let's say you have your email inbox, you search for at which time is my flight going. And then with semantic search, you get the information, hey, your flight is going 5 p.m. on August 4th, 2010. So it's fetching you like an email that's 10 years old. Because yeah, for the embedding, there's like no temporal notion in it. So if there's an email from 2010 that has exactly your words, hey, your flight is scheduled at 5 p.m., it will find and show you this result. So what you often have in search is like these, yeah, not these implicit expectations or assumptions from users. So if I search for at which time is my flight going, I want to know like probably the next flight, so something today, tomorrow, this week. So I'm looking for like my next flight that's going. In e-commerce, you often have it when I search for shoes. There's like a lot of shoes on Amazon, but yeah, it makes a difference. Am I a man, a woman? Am I like what's my age? Do I have kids? Do I have like a son or a daughter? And what age are my kids? And then depending on these, it makes a difference. So maybe I'm looking for my shoes for my daughter who's like 2 years old. So maybe I put just kids shoes in, and in the best case, it shows me like shoes for girls 2 years old. But yeah, this is not in the query. This is somewhere outside. And so it's a fascinating problem how to encode this, where yeah, semantic search with embeddings hitting certain limits. So in the embedding space, you can't have like these temporal relation, and then yeah, people start to hack around and say, okay, semantic match 80%, recency 20%. Try to use thresholds. Let's say, okay, find all emails. At which time is my flight going? So find all emails with a threshold above 0.7, and then rank them based on recency. So like a lot of hacks and tricks going on in the space to really go from like a shiny demo to an actual production use case.
Yeah, I have kind of a couple perspectives on this temporal queries thing. I think like I think it's also quite heavily related to kind of filtered vector search, and for people to understand that you do the HSW graph traversals and you have this like allow, like one way that we do it in Weaviate. There, I could go on about these things, but I probably save that for later. But like you'd have an allow list of nodes that match the filter IDs, and so like date greater than July 5th could be like one of the criterion that lets you traverse the embedding proximity graph. But I think there are quite a few things to this. The first is like like there's kind of like an emerging category of startups around like metadata extraction from unstructured text chunks. So we had Brian Raymond from Unstructured on the podcast. Yesterday I listened to Doc Yugami present at Llama Index, and there's Chima, LangChain, Llama Index. They also have like these data loaders. And so like using language models, or I think kind of like, especially talking to Nils Reimers, like LLMs, we both kind of understand these just mean like deep learning models. It doesn't necessarily have to be like 200 billion parameters to do the task, but like training specializing models on extracting metadata that you can then label each of your text chunks with the date that if it's captured in that, which that's why I really like the example you just presented, and it added a new perspective. Is when you have that query that's like, I need flights for tomorrow, I guess you need to have some kind of query understanding layer in the middle of that. And so that makes me ask you, is that the next Cohere model integration that we'll be doing, is the, the query intent?
Yes. So if you search for which time is my flight going tomorrow, you need to in some integration. I'm not the biggest fan of like metadata extraction, so because then you're kind of like limited to like, yeah, which metadata do you have? What do you extract? Does it match with like the thing you have when we have something like at which time is my flight going tomorrow? Like finding the right email is kind of challenging. So it's not like the most recent email you got was flight information, because this could be a flight somewhere in the future. It's probably not an email which is like 10 years old, but it can be somewhere in between, like 1 year and yesterday. So it's like really, really hard to express this as hard filters or as SQL, where you say, okay, give me, I don't know, if I ask like, at which time is my flight going, find all the flights, emails I got, and then sort them by recency and pick the most recent one. So here we're currently developing smarter ways, a new foundation model in search, where we don't have to do like the tricks with metadata filtering and going from unstructured data to structured data, and then use some language like SQL or whatever, however you express your filters and your ordering, but really do it like in the model itself. Because I mean, it's always appears a bit absurd for me that we have like LLMs and we take LLMs to transform unstructured data to structured data to then be able to search on it. So why not like directly use it in the LLMs, and be able to let them do the job and extract what's needed and then tell me, okay, what's done there.
Yeah, I think I guess there's kind of, I have two kind of reactions to this. The first of which is there's kind of like filters that are like totally unrelated to the content. So like like if I have shoes again and it's like how many of them are in stock, there's like no way of having the embedding know how many I have in my store. Kind of, so I kind of see like that component to filters, but then again, like how an LLM or whatever metadata extraction model similarly would not be able to derive that. And so, yeah, I agree with you. Yeah, it's very interesting. I guess I probably would just need more time to see it all play out to have a strong opinion of my own about this. But I agree with you that like if the LLM can extract the metadata from the chunk itself, then you probably also could capture it in the embedding, and there probably is something to that. Yeah, I guess
Yeah. I mean, these metadata filters, they are nice in e-commerce. We see them like on the left bar, we have like a sidebar where you can filter on the price, where you can filter like the brand, the color, the size. Here, it's always like a question. It's like, you always have like these hard filters where I say, okay, give me anything, I don't know, like some item, let's say a smartphone that's below, like, I don't know, anything below $500. And then I have like a really hard filter that's like anything below $500. But what's the case if there's like a smartphone perfectly fitting what I want? So I was like looking for Christmas for a new smartphone. It should be like small so that it fits well in my pocket. Camera quality was important. Battery lifetime was important. I didn't want to spend more than $500. But these $500 is like kind of like a soft limit. So if it costs like $501 and it's like the perfect phone, yeah, I take it. Also, if it costs like $550 or $599, I say, yeah, it's so much better than anything else. I would buy it. And so I think this is at least what I see and vision like long term, that we can get rid of these filters and just phrase it as a search query where I say, okay, I want a smartphone. Should be small enough to fit into my pocket. Should have like good camera quality, good battery lifetime, and I don't want to pay more than $500. And then the model can decide itself and see, yeah, here I got like a phone, got really highly rated, good feedback, reviews on users. The size is like really small, so it's a tiny phone. But it costs $520. But I think, yeah, 520, it's good enough. And are you willing to go like $20 over your budget? I say, yeah, perfect phone. I'm willing to do this.
Yeah, I get it. This reminds me back to our original conversation on ranking models, where I could have like that like boost filter is kind of like what I like calling it in Weaviate discussions of like what an API would look like. But like, yeah, like, please rank it higher if it's less than $500, but you don't need to be so strict about it. And that kind of thinking about how you do the iPhone. Yeah, like I guess it kind of also reminds, like, it's this topic again. It's very similar to the LLMs extracting metadata. Is the ranking models. It's like if the ranking models can do it, then can the embedding models do it as well? But I think like having that symbolic control, it just makes it so much easier. I guess one other idea. There's this paper called NHQ, which is like you would have embeddings for each of the filters as well. and maybe you could have like a multi-vector ranking thing where you have the pooled vector for the entire, Amazon iPhone, this iPhone that we're talking about, this the description of it, and then you also maybe have like vectors for each of the labels, and so it's still kind of like embeddings, sort of, maybe that kind of thing. But so I think I kind of did want to stay a little more on your skepticism of the metadata extraction with language models, because I think it ties to another one of the topics that we've premeditated is like I find it very related to kind of chunking and long document representation, because I feel like what happens is your motivation to extract metadata a lot of the times is because you're like parsing a PDF, and it's like a semantic category, like it's there's only 100 tokens in this part of the document, but like for a reason it's got like a title, like this is like this legal clause, and then here's like another one, right? Like so maybe if we could kick it off with your perspectives on long document representations, and then maybe we could see if we can tie that back to this kind of extraction topic.
Yeah, so I mean, for now, metadata extraction, it gets the things done, like in many cases. So just say like long term, like I don't know, 5, 10 years, I don't envision the field that we're still go take an LLM, extract metadata, put it into like some relational database, but like, yeah, find ways how we can do it directly. But yeah, to the topic, long documents. Long documents are challenging in embedding search. For a long time, sequence length has been a challenge in transformer models like BERT. It's like 512 tokens. This got recently fixed with like longer sequence lengths, like Llama 2, where we have now open source models up to like 32K. But it's sadly not solving it for embeddings or search. So you can deploy it, but the quality of all these models is terrible. And the issue is that embeddings can encode like one topic at a time. So they can store like one fact. So let's say like the founder of a company and can encode like Mark Zuckerberg founded Facebook. But they struggle if you have like multiple facts. Like let's say you have like a long list of all US equities. So there are like 2,000 or more US equities right now with the founder information. It's like, okay, should I include it like at Facebook or Google or at Amazon or Nvidia? So you get somewhere some strange embedding in the middle, which has nothing to do with the specific information. So what you need to do is like take the long document, break it down into individual facts, and that's the first challenge. Like, how do I know? Okay, this is like a new topic. So am I still with the old topic talking about Mark Zuckerberg and founder of Facebook, or is it the new topic about Bill Gates and how he founded Microsoft? So that's one challenge. Second challenge is contextualization. So you might have like a header, and then okay, this paragraph is belongs to the header. So for example, in annual reports, you have Apple annual report 22nd. In the text itself, it never mentions Apple. It always mentions we or our company. And it also doesn't mention 2022nd anymore. It says our company saw a lot of growth this year. And then the question is like, okay, who's like our company? Who's like this year? And so here, decontextualization approaches are kind of interesting, where you take the long document and you decontextualize it. So if you have a paragraph like our company saw a lot of growth this year, you rewrite it to Apple saw a lot of growth in 2020. And then also to look at like, okay, can we split it into like individual topics, which we can then encode as paragraph in the vector database.
Yeah. I love that. I just had the light bulb go off. But like, I love this idea of like, well, we're kind of trying to call these generative feedback loops, where you use some kind of generative model to like kind of alter the data that is indexed in the database, or just save for any reason kind of. But this particular case of like, like something I love is the summary index, where you take like, these podcast clips and say I'm stuttering, like right, and it kind of will compress that into a summary of the content that I say, and then you embed that summary, and I love that. I think it's a really clever way to build better search indexes. And as you mentioned, disambiguating, our company means Apple. That to me, that sounds like another kind of like generative feedback loop. Use a generative model to fix the data there. So then there were kind of two things I parsed out of what you're saying. The first of which is kind of like generally, language models are getting longer context, things like alibi attention, the details of how that works. I think maybe irrelevant for the podcast, but like generally we're seeing models that can take 8K, 16K, 32K. And it's like, will alibi attention work its way to embedding models? Maybe if I could quickly get your temperature on that, and then we could come back into like multiple facts and maybe because we also have like structured graph data, so I think it would be a nice transition to that. But let me quickly take your temperature on like alibi attention. It's clearly being impactful with Anthropic Cloud and all these kind of things. Will that kind of thing help embedding models?
Sadly not. As mentioned, embeddings only work if you have like one fact in a per text. And there's like not so many texts out there where you say, okay, I have like 8,000 tokens, but it's just, I don't know, repeating Mark Zuckerberg founded Facebook. Typically, if you take like a 8,000 token article, let's say from Mark Zuckerberg or Facebook, there's like a lot of information about Facebook, who founded it, early days, nowadays, transitions to Meta, and so on, which are like all different facts. And every fact needs like a different embedding. So yeah, we can add alibi to it. That's not the issue. But yeah, if you input it like full Wikipedia article and then you search on it, search quality is terrible.
So then this brings me back to the metadata extraction thing, because identifying facts, isn't that kind of similar in a way? Like, because you have to say like, okay, this is one fact, this is two facts in this unstructured text chunk.
Um, yeah, it's kind of metadata. So it's currently like a hack, a trick that gets the things done. So it's totally okay in search. For search for the past 50 years, it always has been like using hacks to get things done. Um, Challenge is always a bit when you do like this decontextualization, which I mentioned earlier, like our company had the best year, or this was the best year for our company, where you replace this year with 22nd and company Apple. Challenges there, like how much should you decontextualize, like how much information should you provide into that. It's kind of like easy for like this really simple one sentence, but if you go in like an annual report, you have like Apple annual report 2020 subsection, I don't know, Europe subsection, I don't know, iPhone subsection, market share of iPhone in Europe, and then you have like some information, like complex information on it. So it's like probably a lot of like context information to understand this paragraph. Well, then the question like, okay, how much do you include? Do you just include it's Apple 2020? Or is it, do you also include like all the information where they talk about like a market in Europe for the iPhone with like certain subset of customers? And then it becomes like really, really challenging again to find the good trade off where you say, okay, you have like this one sentence, but to really understand the sentence, you might need like full paragraph or full page of context information. And then the question is also like how to embed it, where you say, okay, this is the sentence, and here's like the full context to understand the sentence.
Yeah, I love that decontextualization. I think that's a wonderful phrase. Like we've seen like
I mean,
disambiguation.
yeah, like one example right now, we know Donald Trump is front of the court, is tried due to, and we have like a lot of context information where he was not accepting the last US elections. And yeah, Trump fans were storming US Capitol. So there's like a lot of context, out of context information where also the question is like, okay, if I index this news article where Donald Trump is trialed in Washington, do I also provide like all these background information which led to the trial or not?
Yeah, that's fast because like so you would take like one text chunk that's like Trump fans storm U.S. Capitol, and then maybe you'd want to add to the chunk, like, because they believe the election was is quite a topic. Maybe we'll find another example, but that kind of thing of it makes me think like about models at data ingestion. That again, that topic of like the summary index kind of thing, but where you use more models in the process of parsing out your data and building up the index. And yeah, I think it's all very interesting. But yeah, I think this would be a great transition to talking about graph data. I'm not sure if like maybe to transition, like there's kind of two ways that I see about thinking about about organization of facts themselves. You would have like, Nils Reimers works at Cohere and, like authored SentenceBERT, and like you have these relations. And then when I just grab the node Nils Reimers, I can really easily parse out all the facts associated. Or you would take each fact, have a natural sentence for it, and then embed them and search. So I love kind of, I don't have a great understanding of when to use which, but I think those two.
No, it's an interesting road ahead of us. So I really think search is just at the beginning. Current technologies totally fail. As mentioned, if I ask like any search system, at which time is my flight going? They all fail miserably. So this is like an interesting aspect. What we need to see in terms of research in industry, what innovations come in. Like do we use like these knowledge graphs where we represent facts and say, okay, this is a person. They have like this information in their CV, like past publications, past company engagements, and so on. Like more in a symbolic way? What do we do like more in like kind of like an abstract way where we keep like a text record and then the model is able to find the relevant information and quickly um, quickly reason about this. And yeah, right now like finding this information and judging is it relevant or not is kind of challenging. So we all know large language models, they have challenges with hallucination. So if you ask them what are the symptoms of some fake disease, like a disease I just invented, they give you like really compelling writing. What is this disease? What are symptoms? What is the treatment? Because LLMs, transformers, they are terrible in not knowing, in knowing that they don't know it. And that's basically like the challenge in search. Like you need to decide, is this text providing me the information? Is it answering the question or not? Like at which time is my flight going? So here they're like really, really bad at, and we need a lot of innovations and breakthroughs in this space.
Yeah, well, I do have to like hypothesize that the kind of cross encoder would be really great at that. Like, at which time is my flight going? And then, well, yeah, hopefully. I mean, and then it kind of retrieves from your calendar. It's kind of like this whole thing is the way our conversation is evolving is really inspiring me into the whole like retrieval augmented generation, as well as like kind of the agents thing. I think the agents thing ties into at which time is my flight going, and you've hooked it up to tools like my calendar, and so that, and then like that's kind of like there's all these like models in the middle. I find this topic so fascinating because like they're like sorry if this is too much of a tangent, but I like this paper called Gorilla quite a lot, where Gorilla is like a large language model fine-tuned to use a particular tool. So like in the case of the calendars don't have too many APIs, but it's like, how do I format a request to get like Nils Reimers is Friday and like get everything to understand when your flight is. But generally, actually, let me kind of just broadly, how do you feel about retrieval augmented generation right now? And I mean, it seems to me, obviously from Weaviate, like this is like, a huge evangelist. I know, Cohere has like the Coral system, and yeah.
It's a massive topic. So we have this Coral system, which is like an intelligent enterprise agent. So you plug it into your enterprise data, and then you can ask questions like, okay, we have this customer, give me an overview of the customer engagement. Where are we? Which are the latest topics and blogs from this customer? So instead of like you as manager, like pinging the sales rep, you get it directly from your CRM data. So I always have the feeling people put data in Salesforce, but hardly look at it, and instead of like ping people to get a summary. So hopefully we can change that. So yeah, retrieval augmented generation is fascinating. We have like really strong models here on the one side for search, because this is still a bottleneck, and on the other side in generation and citation. So big issue with generative models. If I ask generative model, hey, I don't know what's the size of this company, it spits me out like some number. Like when I say, okay, what's the revenue of Apple? It gives me some number, but I don't know, is it true or not? And I don't know if I used to ask like these generative models, hey, how many students study in my university where I did my PhD? Gave me a number, but it was like a bit off, like off by some few thousand students, and that's like really hard to judge it. And here, citations is relevant to say, okay, I can go back to the primary source and see, okay, here I got the information. So, for example, if I ask the model in an enterprise setting, what's the pricing discount we communicated to that client? You don't want to have like some hallucinated information. So you don't want to say, yeah, we said 30% discount. And then you think, okay, it's 30% discount, but actually you just communicated like 10% discount. Or is it okay in terms of like legal questions? Is it okay to use your software in such a such setting? And then the model says, yeah, perfectly good. But then you say, no, well, how can I trust it? And I think here giving the citation and say, hey, yeah, you can use the setting here, and the source is this email from January where we asked these questions, and based on the answer they provided, we think, yeah, you can use the software in this setting. So you can verify it as a human if it's actually true or not.
Yeah, I think there are so many topics to explore. I mean, the kind of give the citations, I think that's one of the most clear application, like reasons to do this. Like as exciting as LLMs are, the hallucination problem and being able to look at the search results. There's so many interesting things in that, though. Like the question of what is the size of this company. I've been loving saying this recently is that every Weaviate class is jointly a vector index, a JSON index, and as well as an SQL index. We don't have an SQL API, we have an aggregate API, so the syntax is a little different, and it's a little interesting thing of how to interface that. But like you take this, what is the size of this company, and is that a vector search query? Personally, I think it would be better off translating that to like a symbolic aggregate, like this, but then this that clear, right? These concepts.
Yeah, I mean, they're the challenges again. Do you have this in like a relational database or aggregate? Like do you have like a column? I don't know. Let's say employees or revenue. It's also a bit unspecified. Size of company. Do you mean like revenue, profit, employees? In the past, it could also be like physical size of the company, like how many square meters is the company. And here, yeah, I think that's a challenge with metadata, to come back to that. So if you ask like, okay, how many employees work at this company? If you have a column, if you extracted this, it's good. If you just have like the unstructured meta, like unstructured annual reports, yeah, it can just look into like and say, okay, fine, in the unstructured metadata, okay, this is the size of the company, like the number of employees of the company. And then where it becomes interesting is if you do like combinations of like inference of information, when you say, okay, how many employees does Apple have in Europe? So maybe in your database, you just have like, I don't know, from Bloomberg, you get the data number of employees at Apple, but you don't know like employees in Europe for Apple. But like from unstructured data, like some news article, some annual report, some press release, they mention, okay, we have like, I don't know, 100,000 employees, roughly 30% of these are in Europe. And then you can infer from like these two information nuggets, okay, Apple, a good estimate is like 30K in Europe. and so that's fascinating, like where we need to rethink um, how databases work, and we will see a lot of innovations going a lot more into like unstructured only, because with structured you would need to think beforehand that someone will ask like how many employees does Apple have in Europe, and this is kind of like a rabbit hole where it says, yeah, could ask like, okay, how many employees are in Germany, how many employees are in France,
Hmm.
and then it gets like you would need to think about this beforehand when you create the metadata and extract the data.
Yeah, well, all that is why I believe really strongly in kind of the longevity of frameworks like Llama Index, LangChain, like Haystack, Gina is like this kind of, like the like self-ask prompting is kind of like the academic way of like, there's this paper called Neural Databases from James Thorne and others, which is like, yeah, exactly. I mean, you painted the picture perfectly. You decompose a question into like maybe a symbolic question as well as a vector search, and then you later on kind of pool it. And I think that kind of, semantic layer of orchestrating these kind of LLMs and all that will be really interesting. I kind of wanted to stay as sorry to be pivoting the topics, but like when we were talking about retrieval augmented generation a little more and talking about kind of reducing hallucinations as being maybe one of the biggest drivers of this kind of framework, I wanted to take your temperature on retrieval aware training. This is like, for example, I mentioned the gorilla thing earlier. The way the gorilla thing works is you retrieve the AP. You're giving it a natural language command. Like in the example of Weaviate APIs, you'd be like, BM25 search in pod clip, return speaker content. And it will take that natural command and then translate it into the GraphQL that could execute against the Weaviate database. So the way this is trained is you retrieve the API reference, and that goes in the input alongside the natural command and the schema to output the GraphQL query. And I feel like this kind of retrieval aware training could just be so powerful. I'm curious, like if Cohere is thinking about doing this with the LLM, is obviously in the search and all this kind of stuff.
Yeah, um, it's a big focus. So internally and also to alpha customers, we have a really nice RAG model, which does these. So internally in RAG, first is like query formulation. How do you break up your query into subqueries? Execute on these. How do you get the data? How do you create like the subset of data that goes into the RAG model? Let's say you have like a query. Um, how did the revenue develop for the big five tech companies during COVID? So this is not like a single query. So if you work with like annual reports of companies, it's not like a single query. It's like a set of queries. So you need to get the data for Facebook from 2019, from 22, for Google, for Amazon, and so on. And then you need all to prompt this into the generate model. Challenge is with a lot of generate model out there, like Llama, OpenAI, and Traffic, they have not been trained on this, and we trained like extensively on this. So on the internet, you often see like the final result. So you write the final blog post, but you don't see like the research that went into the blog post. Like what were the search queries you formulated when you were informing yourself about the model. And so this is currently what we're doing. It's like showing the research process, like how does a human search for information, which information do they take into account before formulating the response. So bring this capability to the model, and then also be able to reference back and say, okay, this part of the information I got from this source, this part of information I got from that source. So here, yeah, we will see, at least from Cohere, you will see a lot more on foundation model from on this. Models like really understand to search, what to search for, how to reference back information. As it's kind of like a vital, and yeah, I mean, it's a going forward. I mean, it's also the shift we saw with humans. I don't know, when I started to program, I still remember people try to memorize like every function you have in C. So like, okay, you know all the function names because it was like really slow to search. So you had like a big book, and then you need to go in the back in the index and see, okay, which function do I use to, I don't know, sleep my process for a second. But this really changed was like Google and Stack Overflow, where nowadays, yeah, I don't know, there are some functions we always search, Like I always search what are like the arguments for the sort function in Python. And yeah, with Copilot, it's also less and less knowledge needs to be in our head, and we're doing more and more search in the background, and then use the search results to do the next token. And the same will happen with generate model. They will learn how to search and how to take search results into account.
So I think the kind of really interesting philosophical thing for me is I remember Bob had showed me this notebook from Nick Frost, which was like query formulation. So you take the prompt and you don't just send the prompt to the vector database. You first send the prompt to an LLM to ask it what would be the query for this to then query with that and then answer the question that way. And I think kind of for me, it's like, this difference between learning how to search. I think this is kind of, there are a few things to this, but firstly, there's like how to search with Google search, like Bing API, SERP API, and like kind of like the web GPT search actions where you just kind of think about like what query to send, maybe like next page of results versus kind of the gorilla thing, which is like how to particularly use the APIs of like Weaviate and these search databases, vector databases, search engines, like what phrase you want to use. And then I think there's also this kind of really, really interesting emerging category of like end-to-end RAG, where you would maybe put gradients from the reader back to the encoder, and it's kind of learning it in a very neural way, like none of the symbolic layers of either the Bing API or the Weaviate API, but it's just going kind of, and it still would you kind of use Weaviate to store the vector embeddings from the encoder, even if it's learned end-to-end. So kind of these three things are, hopefully that's a not too ambiguous of a question, but like,
Yeah, I mean the final one, this end-to-end, it's interesting but really, really challenging. I mean there was this original retro paper which had like retrieval within the pre-training of the model. So before it predicts like the next token, the missing token, it looks into like a massive vector database to find like similar text. People were extremely excited about that at that time, but it feels like there's like basically zero follow-up. So I haven't seen anyone like reproduce or work on it. Plus the challenge is in these settings, you make it like often like too easy. So in your text, you have like a lot of duplicates. And then the question challenges is when you ask like, okay, what's Weaviate? And then it retrieves the information. There's a similar text, like a near duplicate for the model. It's like really, really easy to just copy paste the words from there. So you don't get like any reasoning world knowledge into the model if you're not extremely careful. So you have to control like how good is the search quality. If it always finds like an exact duplicate of the text you currently do next token prediction on, it will not learn anything. Just like do predict the next token or copy the token from the search results. That's a challenge. Other challenge is engineering wise. End to end means you have many moving parts which you need to fix, and it's like really hard to improve up on individual parts. Let's say if you have an end-to-end system and you see, okay, search quality is not great because it doesn't take like recency, popularity into account. Let's say you do like search over news. You ask, okay, give me insights about the US president's elections, and then gets like information from 20 years ago. In an end-to-end system, you can't go in and fix this one system and say, okay, make the search results better or make the generative better. It's always like, if you want to fix one thing, you have to work on the whole pipeline, search and generate, like search and generation, search and generate. And this makes it like a really nightmare to work on enhance.
I agree 100% with that. I think, and I guess the only, with the RAG end-to-end thing, I'm not sure really where my sentiment is at on now, and I don't want to put out like a bold, too strong opinion yet, but I mean, what you mentioned about kind of parsing out the search results, this kind of brings us to our original topic. This is why I'm so excited about the Cohere Rerankers is like, I read that paper Lost in the Middle that's about how you can't just give it like 20 search results and expect it to find the answer in the 20. And that's why I think the re-ranking, having that top one, is just going to be so powerful. And yeah, kind of you mentioned retro, and I would love to get like to dig it a little further with you. Is that so retro is the idea where instead of retrieving to put it in the input, so like you retrieve text, put the retrieved text in the text input and then transformer, you would retrieve the embeddings and then you put that in layer like 8 out of 12 in the transformer. And I'm not sure I exactly understand the math, but I think it's something like, in that you can like transpose the key and that query key value kind of attention multiplication such that by retrieving the way that you could put like 1,000 embeddings. So you put like a gigantic amount of memory kind of in the middle of the transformer. So yeah, like I'm not sure. Like I think the question is like, is that maybe a better way to do long context? I think might be a way of thinking about it.
Yeah, it's
Yeah.
challenging to make predictions. I mean, yeah, long context. I mean, yeah, we had these memory networks. They were really popular in 2015 with LSTMs. So there was like a big hype on memory networks and putting stuff in memory and scaling memory, which also didn't show to be realistic. So I think kind of, yeah, we need a mixture. So in LLM pre-training, having like on the one side, like closed book is good. So it's the same with let's say students. If we're educating, teaching people how to program, it's good to have like sometimes like closed books task to say, okay, here's a function, I don't know, read in a CSV file, transform the data, write out a JSON. Without looking at Stack Overflow, programming references, or I don't know, asking Copilot to do this. So this really helps students to learn, understand concepts, and to memorize. And it also makes sense in other settings to say, yeah, you can use Stack Overflow or Python references to look for it. You can use Stack Overflow for it to look for solutions. But yeah, in general, for many settings nowadays, like really hard to find examples to say, okay, if you give a task like, I don't know, give me all the prime numbers between 1 and 100 as an exercise to students, yeah, people put it into Google, find it on Stack Overflow or ask an LLM and get the code, but it's not really preventing them from learning. So I think for LLMs, we need something similar. Something need to be closed book. So okay, here you don't have like zero references, like let's say coding. Find me all prime numbers between 1 and 100, and print them as a list. Do this as closed book. Do like another step where you say, okay, you're allowed to search Python references. So here's like the Python reference handbook. And I give you like some hints and say, okay, these functions can be helpful, or make it like really allowed to use everything and say, okay, you're allowed to use all the Google, all Stack Overflow, but then model mostly goes in and says, yeah, I just copy the results. So here you as a teacher need to be like really good and creative and find tasks where there's not a solution yet. So that the student, be it like a human or be it like an LM, still is able to learn something.
I love that. I always love these like deep learning training algorithms that are inspired by human learning. I've never before that thought about the distinction between when you learn something, when you learn better by having it be closed book versus open book. It's extremely interesting and novel thing I've never heard before. Yeah, it's just really interesting. I love like curriculum learning, and I kind of think generally the interesting thing is kind of the extensibility of RAG. Sort of like right now the way we do RAGs with LLMs is the LLMs are trained with language modeling, but we just augment the input data and it works that way. And I think with retro, there's another paper called Memorizing Transformers that shows we can, and I think retro is like you can retrofit. I think that's like what the name means, that you could take an existing LLM and extend it with that layer 8 attention. So Yeah, it's all super interesting. So yeah, awesome. So I think kind of an anchoring podcast is you tease that maybe you had a bit of an announcement, but not too much. And if we could talk about this kind of, I think we've already sort of talked about it a bit in the podcast, but this kind of foundation model for search.
Yeah, so as mentioned, search still has many challenges. Long documents, temporal information, multiple fields, multimodality, uh, popularity, recency. So yeah, my team is currently working on like a new foundation model for search to really address all these aspects. And yeah, it looks really cool. So looking forward to talk a bit more on this in the future. But really, yeah, we want to tackle most of these problems. So obviously there will be challenges going forward, but we hope to do like a leapfrog jump like in this space. And yeah, stay tuned for more announcements on that.
Yeah, that's of course so exciting. And I really want to also ask about kind of, like I think Cohere offers fine tuning embedding models. And I guess kind of my thinking about how fine tuning works generally is that the better the foundation model, the more effective fine tuning. And then there are all these questions about like, what are you paying for? Like some kind of guarantee of model performance. Should you get to have the weights or just like have the API host? All these kind of questions. And so I'm curious, like with new foundation model for search, and then will that be able to will you not even need fine tuning? Because I also feel like kind of the sentiment on fine tuning is like some people hate it, some people love it when I talk
Yeah.
about
Yeah. Um, in general, I think yeah, we try to get away with as little fine tuning as possible. So
it.
So fine tuning always in the past meant you need a lot of data, and yeah, no one wants to create like a lot of data. Um, so for example, we had like one customer says, okay, we love search results that contain a table because tables are really relevant for our users. So like a markdown table. How can we get them at position one? And with fine tuning, it would be like embedding models. Yeah, annotate 10,000 examples where you search for, where you have like two results, both are relevant, but the one with the table should be more relevant, and then fine tune the model. Where obviously they say, yeah, no, we're not Google, we're not able to create like these 10,000 examples. So one way is how can we put it into the foundation model that we give like these instructions for search and say, okay, if you find two results, both are on the topic, prefer the one with the markdown table or in podcast. First check, is the content relevant to the search query? And then prefer like recent podcasts and popular podcasts over non-recent, non-popular podcast. And the other aspect is like, how can we still include these preferences or get the preferences quite quickly and encode it in the model? Because preferences can be different depending on the company. So in new search, you extremely care about recency. If you run an archive, and you say, okay, here like historic news articles, you don't care so much about recency. Recency can change on users. Some users say, okay, I'll just listen to podcasts at most a month old. So I would say, no, it's super interesting to also listen to podcasts 10 years old. Can depend on the setting, like in sports. Yeah, no one listens to like 10 years old podcast focus on sports. But in other, like let's say art, I don't know, true crime, you say, yeah, it doesn't matter if the podcast is like 10 years old or 1 month old. It's still true crime. It's a nice story. I care more about like popularity and then is there like a good personal fit. And so this is like going forward, your working block for us. How can we enable non-expert users to really steer the model? First approach is with the prompting, that you have like some easy way to communicate it. And then going beyond prompting, have efficient ways where you show like 50 examples, 100 examples. And then based on these 100 examples, the model is able to understand you.
Yeah, I think that's always been the goal of deep learning, is try to learn with as few examples as possible because of the painstaking effort of collecting big data sets. I love that kind of maybe language models could generate synthetic queries from your documents if all you have is documents. I love that angle. I mean, I think it's been one of our number one topics throughout this whole podcast is how do I boost based on does it contain a markdown table? And, maybe the ranking models could take that kind of prompt of like, please, if it has a markdown table, or if you've extracted that metadata where you have like a contains markdown table true, and, you promote those results. So yeah, all of it sounds so exciting. Nils, thank you so much for joining the Weaviate podcast. It's, so great for me to learn about how you're thinking about all these things. I'm sure all our listeners will love this. And yeah, thank you to our listeners and everyone at the Weaviate team that enables me to have conversations like this. This really helps my education and knowledge of deep learning and search. Nils, thank you so much.
Great. Thank you so much.